Hi, I'm Melanie Olson, and I'm a classroom teacher from Buffalo, Hanover, Montrose schools. And today we're going to talk about easy computer science integration. And more specifically, we're going to talk about unplugged activities. So, when we talk about integrating computer science into our classrooms, it's very important to focus on computer science pedagogy principles. And unplugged activities are a great way to do this. They actually incorporate all of them. And so, it's a great chance to give kids an opportunity to explore the principles and with hands on activities that are going to engage them and get them excited about computer science. Today, I'm going to share with you my very favorite unplugged activity, and it comes from code.org. And here is their promotional video. I share this even with my students just to get them excited about what we're going to be doing before we do the activity. So here it is for you. Nope, got to back up. There it is for you.
This is a fantastic lesson called My Robotic Friends. It's a lot of fun. We teach programming without using computers. So we get groups together where people program their robotic friends to stack cups in a certain configuration just by drawing arrows on paper. So right now we're implementing the activity that they've been working on. We had a programmer who wrote down this program using arrows, and we have a robot who's reading the arrows to try and figure out what they need to stack using the cups. So she'll translate the arrows into specific movements to try and make one of these stacks.
All right, so to get started with this activity, the materials that you're going to need are number one, the symbol sheet, which is the sheet with arrows, a student worksheet, which is something that I created to organize student thinking, and I think it's very helpful in implementing the activity. A bag with cups and stacking picture, which is my organizational strategy on how I just like to keep my materials together. And that's the Ziploc bag at the bottom of the picture. I keep all my things in a very cute code.org bag that you would have to get on your own. And of course, you would need some writing utensils, pencils, and a highlighter. So the symbol sheet that students are given shows the what they're going to be using to write their program. And so everyone's using the same symbols, so everyone's on the same page. The one thing that is very important to point out, and it's not written on the symbol sheet, but the symbols for moving one step forward and one step back is actually moving 1/2 cup width. And so that's very important to point out to them. That is often the most common error that students make if they miss that. Another key point to point out to students is a programming rule or norm that they will become accustomed to is that when you start a new line of code, it is assumed that you are picking up a new cup in this program. The student worksheet that I created is really just used to organize student thinking. So there's a place for the programmers to write their name at the top of the paper, the program letter, that'll make more sense on the next slide when I show you how I organize my materials, and then it gives them a space for them to write their program. The first group will only do the top half of the worksheet. The bottom half will be completed by another group of students who are acting as the robots. So Here's an example of what the cups look like in my classroom. So for me, I have all of my materials in a big Ziploc bag, and it's filled with smaller Ziploc bags. Every single group gets a sandwich size bag. It's got their code picture on it of what they're going to be creating. It's got all the cups that they need to make that specific picture. And then I've also decided that for me and keeping things organized so that I have everything together is I've assigned a letter on each card and I've put it also on the back. So hopefully those things come back together at the end of the activity. So you will be telling your students that your group is going to write a program using the symbols to help a robot recreate the picture that you're given. And here you can see an example of a very simple picture of stacking that the students might have. Every group will have a different picture. So the programmers, their procedures are to write the program for the picture that their group is given. Check your work. I always ask them when they're done writing the program, please go through and follow it as if you are the robot. Oftentimes they'll catch something. Rewrite the program if needed. When they're all done, they're going to remove the picture from the bag because we don't want to give away the answer key. They will give that picture to me and I will hang on to it. They will then switch materials with another group. So when they're acting as the robots, the number one rule is you may not speak to the programmers. They may not ask questions. They cannot ask them to clarify. If they cannot read the program because it's written a little messy, it is what it is. They have to follow what they're given, just like a computer would. So they're going to follow their program to recreate the cup structure, draw a picture of what they've created because the students will have seen what their picture looks like. It's often easy for them to recreate a little picture of what their product looks like when they're done. Then I have them raise their hand and check with me. I will bring over the picture, the little answer key, and take a look at what they've created. If their picture does not match the answer key, then the group is asked to debug the program. So they're going to find what part of the program didn't work. They'll use a highlighter and they'll show the part that they feel the programmers didn't quite write specifically. And then on the back of their paper, they're asked to rewrite the program the way they believe it should be written in order to be able to follow it and produce the same picture. So here's an example of student work, and this group worked really well together. They had great collaboration, they had great communication, they wrote their program very clearly. You can read the arrows very nicely, and when they gave the program to their robotic friends, the robotic friends were able to easily follow the program and recreate the picture. So they had great success. Here's an example of a group that had some errors in their program. You can see below on the pictures what actually ended up being created when they followed it exactly. And so the robots were then charged with the task of reprogramming or debugging the program, and they really had to think about specificity and how they need to write it so that they would come to the correct end result. If you want to take this activity to the next level, there's a lot of ways that you can do that. The first one is I would have students create their own cup pictures of what they want. I know in our physical education class, they've gotten into cup stacking as one of their activities, and so the students have had a lot of ideas of what they think those structures should look like. They've also learned that the more complex their structure is, the more complex their program will be. You can also incorporate other items than cups. You'll notice that in the code.org video, they used large solo cups. I use small Dixie cups just because it's easier for me to travel with and store them. You could also use a number of different math manipulatives that you have as long as they are similar and consistent in structure. You could use books that are the same size. You could also consider altering it to including movement or dance. You could make a human pyramid. You could have the students code a dance routine that they have to follow when they're given certain instructions. You could have the students even create a new recess game. There's really not a limit if you allow the students to have choice and use their creativity to be able to come up with something new. And so here are the links that will be live in the Google Slides that are shared with you for this presentation that I used. The top one is the student worksheet that I created in a Google Doc to help organize student thinking. The second is a PDF of the original code.org lesson plan, the one that I shared with you today. And then the third one is the current lesson plan that's linked on code.org, and it's my robotic friend Junior. One difference is it doesn't have the rotation of the cups in it, and so I believe it's a little bit simpler. And so I've linked both of those there for you, and I hope that you choose whatever works best for your class. If you have any questions, I'd be very happy to help you in any way that I can. I hope that you enjoy this activity and now you feel from getting an idea of some organizational strategies that you would be able to easily implement this as an activity in your classroom. I know the first time you do it is going to be the trickiest time, but hopefully these ideas have given you a way to think about how you could do it quite easily. So thank you for sharing your time with me. Have a great day.